So still working on Venus is why it's so hot. In the last video, we said that light from the sun can come down, hit rocks, and the rocks sort of spit the infrared light back up again. So they use all the visible light and other bands like that, but the infrared goes back up. And this simulation sort of shows you all that happening all in one simulation. So let me just show you a couple things about this before we go on. So you can see sort of a landscape here, in this case some grass and some buildings. So this wouldn't be Venus, but this doesn't just apply to Venus, it applies to any planet. In this case it's sort of around the Earth. And so what you see here is all these little yellow sunlight photons coming down. Watch a few of them going down. And you see the red ones going back up again. And so that's sort of exactly what we discussed here in our last video. So let's just make sure that we're clear on what's happening. Is that, of course, here's Venus here on the ground. And what the simulation shows you then is the yellow light coming down. So it's sort of like sunlight. Then it shows you these red photons going back up. And these are the infrared. Going back up again. So that's sort of the key aspect of what's happening here. Okay, so back to simulation now. So you can just watch it, see all the yellow photons going down, and all the red ones going up, the infrared photons going up. And so it doesn't look like a lot's happening. In fact, it looks very cold here. Here's a thermometer here, which says they're sort of at about 0 degrees Fahrenheit. Okay, remember water freezes at 32 Fahrenheit, so we're a little cooler than that even. Okay, cooler than where ice freezes. So we're kind of, sort of in a cold environment, even though we are getting hit by sunlight. So now watch what happens now. You can't quite see the slider on your screen, but what I'm going to do is I'm going to increase the carbon dioxide concentration in this simulation. You can barely see my mouse cursor right here where it sort of points. There's a little slider right here that I'm about to drag over. So let's just add some CO2 into the atmosphere by just dragging it up a little bit. Okay, there we go. And I hope you can see something happening now. So it doesn't really look like the graphic changed very much, but what happens now in this region here of the sky, there's more CO2. And so can you tell what happens? Can you watch a red infrared photon and tell what happens once in a while? Yeah. Hopefully you can see that once in a while an infrared photon goes back down. Okay, so what I'll do now is I'll drag my slider back to get rid of all of the carbon dioxide from the simulated atmosphere, and we'll watch the red photons once again. See, they're all just kind of going up. All just kind of going up. And now if I turn that greenhouse gas concentration on again, I'm going to drag the slider over. You can tell once again that every once in a while the infrared photons start to go back down again. There you go, just happened there. Go again. Okay, so what's happening now? Well, in this case over here that I've drawn here, here's those infrared photons going up. But if I add a little bit of carbon dioxide to the atmosphere, say maybe I'll add a CO2 molecule right here, okay, what happens is this red photon will go up, go up, go up, and when it interacts with the CO2 molecule, as we saw in the previous simulation, it can go in any direction. Yes, it could go this way, it could go that way, it could go straight up, but some of them go back down again. This is very important here. These are the important ones, the ones that go back down. We go back to the simulation now. And so you just sort of watch simulation. Maybe you can track when it actually goes back down, like this one right here. It goes back down, gets absorbed by the rocks, comes back up again, maybe in a slightly different area, whatever. But what you can tell then is that it appears as if the concentration of red photons near the surface of this planet is starting to increase a little bit. Let me turn up the carbon dioxide concentration even more, so dragging my slider even more so. The more CO2 I put in, the more the infrared photons can be sent back down again by the CO2. Of course, they can go in all directions, but some of them go back down. Okay, so what I'm doing now by increasing the carbon dioxide concentration is I'm adding more CO2 and more CO2 and more CO2 into the atmosphere like this. Remember, all these gray things here are CO2. And what the CO2 does, once again, if a red photon goes up and hits it, the carbon dioxide is going to send the red photon back down again, back down again. So maybe if there's more CO2 in these areas right here, the red photons are all going to start being sent back down again by that CO2. Let's watch some more. So I'll increase the concentration even more. And you can see that in the graphic anyway, the sky is starting to get a little less dark in the blue, a little less pure in the blue. It's getting a little more hazy, a little whitish in there. You see a lot of red photons getting sent back down and up and down. It's like they're bouncing around between the CO2, and that's exactly that scattering process that's going on in there. And you see the photons doing it just sort of wonderfully in this simulation here. So you can definitely see that if you were a red photon in here and you get sort of, maybe you're going up out of the rocks like this, you get hit by this, you hit this CO2 molecule right here, you might go back down, hit this one and go back up to hit that one and go down. You just sort of start bouncing around in here. Or the word you might use for this is you might use the word trapped. Trapped infrared. You might use that word in there. Let's watch the simulation some more. So it's been running while I've been talking over there. And look at how these red photons, these red infrared photons, which are associated with heat, are just hugging the surface. And if I turn up the slider all the way, here we go. There's a slider up all the way. First of all, you can see how the sky has gotten sort of a bit milky white in there. It's not that nice deep blue anymore. And look at how all these infrared photons are just hugging the ground. And the other thing you'll notice is look over at the thermometer right here. We're no longer at 0 degrees Fahrenheit. We're at 70 degrees Fahrenheit. The planet has gotten a lot warmer. So I'll give you a little bit of a wrap up on this in the next video, but just watch the video here how these red photons are just all over the ground now. And it's getting so violent, some of them even escape the video screen. They're going all over. Okay, wrap up in the next video.